Have you ever wondered what lies beneath the surface of the planets in our solar system? How do we know what they are made of, how they formed, and how they evolved over time? In this video, we will explore how scientists use various methods and data to study the interiors of the planets, and what they have learned about their structure, composition, and dynamics. Join us as we take a journey to the center of the solar system. Welcome to my channel called Astroverse Exploration. Please like and subscribe for more content about space. And stay until the end of the video for more ways scientists look at planets in our solar system. Now let's continue into the video. One of the most common ways to study planetary interiors is to measure their gravity and magnetic fields. These fields reveal information about the mass, density, shape, and rotation of the planets, as well as the presence and size of any metallic core. For example, Earth has a strong magnetic field that protects our atmosphere from the solar wind and solar flares. This field is generated by a large, hot iron core that rotates inside the planet. Conversely, Mars does not have a strong magnetic field, indicating that its core is either smaller, cooler, or less active than Earth's. Gravity and magnetic field measurements can be obtained from orbiting spacecraft, such as NASA's GRACE and MAVEN missions. The terrestrial planets are composed of mostly silicate rocks and metals, such as iron and nickel. They have a layered structure with a thin crust, a thick mantle, and a dense core. However, they also have some distinctive features that make them unique. Mercury, for example, has the largest core relative to its size among the terrestrial planets, accounting for about 85% of its radius. This is because Mercury lost most of its outer layers during a giant impact early in its history, leaving behind a mostly metallic core. Venus, on the other hand, has a very thick atmosphere that traps heat and creates a greenhouse effect. This makes Venus the hottest planet in the solar system, with surface temperatures reaching up to 480 C. Venus also rotates very slowly, taking 243 Earth days to complete one spin. This means that Venus has a very weak magnetic field and no plate tectonics, unlike Earth. The gas and ice giants are composed of mostly hydrogen, helium, and other volatile elements, such as water, ammonia, and methane. They have a very different structure from the terrestrial planets, with no solid surface and a thick atmosphere that gradually transitions into a liquid or solid core. Jupiter and Saturn, the gas giants, have the largest and most massive cores among the giant planets, consisting of rock, metal, and hydrogen under very high pressure and temperature. They also have the strongest magnetic fields and the fastest rotation rates in the solar system, creating powerful storms and auroras. Uranus and Neptune, the ice giants, have smaller and colder cores, consisting of water, ammonia, and methane ices. They also have thinner atmospheres and weaker magnetic fields. But they have more complex and dynamic weather patterns, such as clouds, winds, and seasons. In this video, we have learned how scientists study the interiors of the planets in our solar system and what they have discovered so far. We have seen that the planets have a variety of internal structures, compositions, and dynamics, reflecting their different formation histories and geologic processes. Studying planetary interiors helps us to understand how the solar system evolved, how the planets interact with each other and their environment, and how habitable conditions may exist or have existed on some of them. However, there are still many mysteries and challenges to be solved, such as the exact nature and origin of the cores of the gas and ice giants, the role of water and other volatiles in the interiors of the terrestrial planets, and the possibility of subsurface oceans and life on the icy moons of the outer planets. To answer these questions, we need more data and observations from current and future missions, such as NASA's Juno, Cassini, InSight, Europa Clipper, and Dragonfly, as well as more experiments and models to simulate and interpret the conditions and processes inside the planets. Thank you for watching this video, and I hope you enjoyed it. If you did, please like, share, and subscribe to our channel for more videos on planetary science and exploration. See you next time.